Ever wonder if Ford really builds an F-150 in 24 hours? Here's the truth that shocked me the first time I dug into it. A finished truck rolls off the line about every 53 seconds, but each individual F-150 still spends around 20 hours moving through stations from raw metal to road ready. That pace sounds wild until you see it up close. A Ford plant manager once joked that every minute someone there builds a truck. He wasn't kidding. I'm Morgan Lane, a certified automotive safety specialist. I've investigated recalls and lived in service bays for years. I love taking you behind the curtain so you can feel confident about what you drive. Today, we'll walk the whole line, step by step. We'll look at quality checks, safety parts, and the new steps Ford uses to stop problems before they ever reach your driveway. Have you ever visited an auto factory in person? If you have, tell me what part stuck with you. If not, picture this: a river of parts, people, and robots moving in rhythm. That's how a truck per minute happens without cutting corners. Ready to see what fills those 20 hours? Let's start at the beginning with the metal that becomes your truck. So, is an F-150 really built in a single day? Sort of. Here's how I explain it to friends. The line finishes a new truck about every 53 seconds. That's throughput. But your specific truck takes roughly 20 hours to make its full trip through stamping, body, paint, chassis, and final tests. That's cycle time. Many trucks are being built at once, like dishes moving down a long kitchen line, each station doing its part. This scale isn't new for Ford's top truck plants. Kansas City has been one of the world's busiest, cranking out close to 500,000 vehicles a year on multiple lines. Years back, a reporter watched and wrote that vehicles were coming off one a minute. The math checks out when you look at how stations overlap and never stop. As a safety guy, I always ask, how do you keep quality tight at that speed? The answer is design, discipline, and a lot of automated checks you'll see shortly. But first, if a truck is flying down the line every minute, what are they actually building at the start of those 20 hours? It starts with a big change Ford made in 2015. Let's talk about the metal itself and why it looks different than you might expect. Here's a twist I love telling folks. The F-150 body is mostly aluminum, not steel. That switch in 2015 dropped a massive chunk of weight, over 700 pounds compared to the older steel body. Lighter weight means better fuel economy, and owners saw anywhere from about 5 to almost 30% improvement, depending on the setup. That's big for your wallet and for emissions. But weight isn't the whole story. People ask me, is aluminum tough enough? Yes, the safety results speak loudest. The redesigned F-150 earned a top safety pick from IIHS and a 5-star NHTSA crash rating. Ford didn't do this with soda can metal. They used strong 5000 and 6000 series aluminum, similar alloys to what you'd see in heavy-duty military hardware, then shape it so the cab acts like a protective shell. And Ford didn't throw away steel. The frame stays high-strength steel, tuned to be lighter and still strong. The mix lets the truck save weight without losing backbone. That's how you get performance and safety in one package. So now that we've got aluminum sheets ready, how do those flat blanks turn into fenders, doors, and a full cab? Time to step into the press shop and watch the heavy hitters. Think someone is hand hammering each F-150 panel? Not a chance. Picture presses the size of houses. Ford added multiple tandem press lines just to form aluminum parts fast enough for truck volume. Sheets go in and out, pop fenders, doors, floors, and roof skins with crisp edges and clean curves. Then the robots take over. In the body shop, hundreds of robots lift, place, and join those panels with incredible precision. I've stood beside these arms at work. They insert self-piercing rivets, run beads of structural adhesive, place roofs and doors, and even hand off completed body shells to the next zone. The coolest part? The same robots also scan the finished shell to check fit and alignment. It's like they build it and grade their own work. People are still right there, guiding, loading, and fixing small issues fast. That human plus robot partnership is how you keep a truck a minute without losing control. Now we've got a shiny body shell, but aluminum doesn't love traditional spot welding. So how do these pieces stay locked together under hard use? The answer is clever fasteners and some serious superglue. Let me show you how the shell becomes one solid unit. This surprised me the first time I saw it up close. Much of the F-150 body isn't spot welded like old steel cabs. Ford leans on high-tech fasteners and adhesives that are perfect for aluminum. The star is the flow drill screw. The screw spins at very high speed and presses straight in. The friction makes heat, softens the aluminum right where the screw goes, and the metal forms long, deep threads around it. No pilot hole, no sparks, just a strong, clean joint. For two-sided joints, the line fires self-piercing rivets that clamp layers tight. Where welding does make sense, like in the bed floor to cross members, spot welders still pop in a neat grid. Then the robots lay down continuous lines of structural adhesive along seams. I call it liquid welding. The glue spreads load through the whole joint and captures stiffness you can feel when a door shuts with a solid thud. Put screws, rivets, welds, and glue together, and you get a stiff, quiet shell that holds up to work. Now this body needs its backbone and legs. So how do we marry an aluminum cab to a steel frame with axles, wheels, and everything else? Watch how the skeleton rolls in under the body. Here's the part I always lean in to watch. While the body shell waits, a high-strength steel frame rolls in on a parallel line, already fitted with the front and rear axles, exhaust, and more. Think of two Lego pieces sliding together. The body is lowered onto the frame and bolted down at key points. That's the moment it really becomes a truck. To keep speed up, wheels and tires arrive already mounted on rims. Workers grab them, set them on, and torque them down. It's simple, fast, and consistent. Meanwhile, the frame itself has been on a diet too. Ford moved to roll-formed rails on this generation, trimming about 60 pounds while keeping strength. Little savings like that matter when you add them up across the whole vehicle. Once the cab and frame are hitched, teams hook up brake lines, electrical connectors, and cooling pieces. The truck now has a heart, legs, and lungs. It can sit on its own wheels and move to the next chapter. But it can't leave the plant looking like bare metal, so how do you make paint stick to aluminum and stop corrosion where steel meets aluminum? Follow me into the paint shop and the dip tanks. You can't just spray paint on aluminum and call it done. Ford built a paint process tailored to it. First up is a pre-treatment bath that etches the aluminum so primer grabs tight. After color coats go on, the protection gets serious. The aluminum body and the steel frame each get their own electrocoat primer, called E-coat. Keeping their coatings separate helps block galvanic corrosion, that reaction you get when different metals touch, and share moisture and current. In spots where the two meet, Ford uses zinc-coated brackets as protective buffers. There's an environmental layer here too. The modern paint system runs clean, with emissions well below required limits, and the plant recycles a huge portion of aluminum scrap right on site, feeding it back into new coils. That kind of loop cuts waste and cost. If you're into factory deep dives like this, hit subscribe to Recall Roadmap with Morgan so you don't miss the next breakdown. I verify the numbers and translate the jargon so it's easy to follow. Alright, our truck is painted, sealed, and shiny. Now the big question I always ask, how do we know each build is actually straight, tight, and safe? Let's head to the inspection zones where lasers and cameras look for trouble in seconds. What catches a 1mm mistake at full speed? Lasers do. After the body is assembled, an automated station scans each truck at well over 100 key points in about 40 seconds. Cameras and sensors measure panel gaps, hole positions, and joint alignment, and they compare everything to the digital blueprint. If anything looks even a bit off, the system flags it instantly. I love this part because it's quiet but intense. Lights flash, cameras click, and a screen says okay or not okay. Machines don't get tired, and this is where that relentless pace stays honest. But it's not just robots. When a scan says something is questionable, that body is routed to a separate area where trained inspectors go hands-on. The goal is simple. Catch it early, fix it early, and don't send a mystery further down the line where it gets harder and costlier to correct. So when a unit is flagged, what exactly happens next? And how do they make sure the final, fully built truck is ready for you? Let's step into the laser lab for diagnosis and then hop over to the pre-delivery test pad for a short drive. When a body is flagged, it gets a precision exam. A laser scanning cell maps the area and a computer points to the exact cause, like a misaligned hinge or a slight distortion at a weld point. Technicians can correct it there before the truck moves on. That saves time and keeps small issues from becoming big headaches later. Once the truck is fully assembled, it goes through pre-delivery checks. The team powers it up, listens and watches. They cycle lights, test electronics, and do a short roll test. I've worked with techs who can tell by the feel of a door slam or the sound of a fresh engine idle if something isn't right. That experience is priceless. It's the last line of defense after all the robotics and software have had their say. Only after passing that gauntlet does a truck earn the nod to ship. That's when the barcode says go and the unit heads to a lot or a train. We've seen how careful the process is, but has all this new rigor actually changed the recall story? That's the proof I care about most. Let's look at how Ford changed its approach in 2024 to build trust and avoid issues up front. Do all these checks really stop problems before they reach customers? The short answer is yes, and Ford was blunt about it. After a wave of recalls in past years, leadership changed the launch playbook. For the 2024 F-150, they held trucks in the plant 3 to 6 weeks longer for extra tests. At one point in early 2024, about 60,000 new trucks sat at plants and storage yards, while teams checked and fixed items before shipping. That delay paid off. Ford reported avoiding roughly a dozen recalls on the 2024 F-150 because of the new checks, and early defect rates after launch dropped to the best level they've seen in a while. Normally, defects jump around 70% right after a new model hits the street. This time, that spike was much lower. That tells me the factory steps we watched aren't just for show. They are there to protect drivers and to keep trucks out of service bays for avoidable issues. So where does that leave us? With a truck built fast, but checked carefully, let's bring it all together and wrap up what these 20 hours mean for you, your safety, and your peace of mind. We just watched a modern truck get born, start to finish. Stamping presses shape aluminum. Robots and people join panels with screws, rivets, and glue. A steel frame gives it backbone. Paint and e-coat seal it from the elements. Lasers scan over 100 points in seconds, and pros use sight, touch, and sound to catch the last little things. And when needed, Ford even holds trucks back to make extra fixes before they ship. As a safety investigator, that's the kind of discipline I want to see. If this deep dive gave you new confidence in how your truck is built, subscribe to Recall Roadmap with Morgan for more behind-the-scenes guides, recall alerts, and clear repair advice. I keep it simple, calm, and fact-based so you can make smart choices. Thanks for watching. Which part of the assembly impressed you most and why? Was it the robot scan, the flow drill screws, or the final test drive? Drop your thoughts. Your feedback guides what I dig into next, from plant processes to owner checklists. Drive safe, stay curious, and I'll see you on the next one.